This video will demonstrate how to present acoustic parameters measured under various conditions using the project window in Dirac. In this case, we will show the impact of pre-averaging on the impulse response to noise ratio INR and the reverberation time T20. The hardware consists of an omnidirectional microphone and an omnidirectional sound source, each connected to a 2755 power amplifier that now serves as a power USB audio interface to the PC. We plug in the sound device, which is then adopted by Windows as the default output device for Windows sounds. We change this back to the laptop's internal speaker, here Realtek Audio. Because we already set up this hardware configuration in Dirac before, we can immediately open the measurement window in Dirac to prepare the measurement. We fill out the measurement window, pink MLS as the stimulus for an impulse response measurement of length 0.34 seconds in this low reverb office, and a single omnidirectional microphone. On the Device tab, we select the proper sound device, which is available from an earlier setup. On the Channels tab, we check the output and input channel 1 and uncheck input channel 2, which is not used in this case. We click the Test button and set a suitable output level using the gain slider, high enough to easily exceed the existing background noise level and low enough to avoid evident loudspeaker distortion. On the Project tab, we enter a project name, here T20 versus background noise and pre-average, and a group name, background noise low pre-average 1. Pre-average is the number of responses over which the average is calculated before calculating the impulse responses from it. We check autosave, so that after each measurement, Dirac will automatically save the resulting file, assigning a file name. Note that this assigned file name is user-definable via the Setup menu. We also check Add to Project, so that Dirac will automatically open the Project Parameters window, and after each measurement add the file to the current group in the project. We click the Folder button and browse to the folder the resulting file should be written to. Note that most information on the successive tabs will be saved with each file for calculations or later reference and can be modified afterward. We can enter the environmental conditions on the Environment tab. On the User Info tab, we fill in the engineer and our specific measurement condition, background noise low. The Position tab, normally used to enter information on the source and receiver positions, is omitted now. To get an idea of the measurement stability over time, we perform each measurement 3 times. Therefore, on the Auto Measure tab, we check Auto Measure and choose 3 measurements per take without pauses. Now we start the measurements and wait until they are finished and the results are shown in the project window. Note that we will start arranging the windows as soon as the project window is opened during the measuring process. The project window shows a project tree in the left pane and a preview of the impulse responses in the right. A file selected in the left pane is also selected in the right. The preview impulse responses give a quick impression of their quality, and one can be viewed in more detail by double-clicking it. Clicking the Graph button opens the graph view, and from here we can select wanted parameter from the top right drop-down list, or, if not yet present there, from the Properties dialog box, where the graph settings can be managed. After choosing T20, we see 3 thin curves and 1 thick average curve. We can toggle the component file selection using the right mouse button and show either the standard deviation or min-max curves. And by selecting a file in the tree and then stepping up or down using the cursor buttons, the corresponding curve will appear or be marked. Now the measurement is repeated with an additional background noise source present. In preparation, on the Project tab in the Measurement window, we enter group name Background Noise High Pre-Average 1. And on the User Info tab, we adapt our comment to Background Noise High. Now we turn on the noise source and start the measurement, after which the noise source is turned off. The impulse responses look noisier now, and the new T20 graph differs from the first one. The high background noise group shows a variation across the measurements that is significantly larger than that of the low background noise group. From inspection of the INR, it is clear that at several frequencies the additional noise has reduced it well below 35 dB, which is the target minimum for T20. We can improve the INR by increasing the measuring time, either by pre-averaging over multiple responses before calculating the impulse response, or by increasing the stimulus length. In each case, doubling the measuring time will improve the INR by maximally 3 dB. Now we repeat the measurement at a pre-average count of 16, aiming at an INR improvement of 12 dB. In preparation, on the Project tab in the Measurement window, we enter group name Background Noise High Pre-Average 16. The impulse responses look better now, and the variations in the T20 graph have been reduced. The INR has increased significantly, largely meeting the expected 12 dB rise, which explains the improved results. This brings us to the end of this demonstration. Thanks for watching.